Hi, this is Universe Addicted. Welcome to my channel. Hi guys, this is Universe Addicted. In today's video we gonna see about one of the most important object in the universe. Yup, they are stars. How they form, what are their stages, how they end their life, these questions are answered in this video. There are 7 stages in the life cycle of an star. Giant molecular cloud, a protoster, T-Tauri phase, main sequence star, red giant, fusion of heavy elements and supernova or planetary nebula. In today's video we gonna see about the stages. Before going into the video, if you're new to our channel, please subscribe the channel and click the bell icon. Stars are the most widely recognized astronomical object in the universe and most fundamental object in building blocks of galaxies. And also stars are the responsibility for the heavy elements in the universe. Stars are relatively forms in the dense concentrated interstellar gas, are also known as molecular cloud. Hydrogen molecules are the most common molecular cloud. This region is temperature extremely cold, just slightly higher than the absolute zero. Due to this, the atoms are tightly concentrated and leads to high density. When the density reaches a specific point, the core of the molecular cloud collapses under their own gravity. The core is the mass about 10⁴ solar masses. As the large molecular cloud collapses, it breaks into several fragments of clumps of mass up to 10 to 50 solar masses. These fragments are turned into the protostars. Then comes the protoster. Once a clumps of mass is separated from the giant molecular cloud, each clump has its own unique gravity. And all the clumps are collapsed under their own gravity and forms the protoster. Protoster is only 1% of its final mass, its mass increased by the infalling gas towards it. As the protoster forms, the hydrogen gas around it infall towards its center. Due to kinetic energy, the infalling gas produces heat which increases the temperature and pressure in the core of the protoster. The temperature of the protoster approaches thousands of degrees. Until this formation, the star is not visible to the visible wavelength, because it is obscured by the thick gas and dust around it. After this comes the T-Tauri phase. As the young protoster becomes the hydrogen-burning star, it produces the strong stellar wind, which pushes the surrounding gas and molecules and also produce a flow of gas from the poles. This is the early phase of life of the main sequence star. This phase allows the star to become visible for the first time. Astronomers use radio and infrared wavelength to detect it. After this comes the main sequence star. As the young star reaches the hydrostatic equilibrium, means gravity compression is balanced by its outward pressure from the core, which gives an solid shape for an star. Once a star reaches this stage, it spends 90% of its life in this stage by fusing the hydrogen into helium via nuclear fusion in its core. Some astronomers call the main sequence stage as adulthood stage for an star. How many years a star remains in this phase depends on the mass of an star. Bigger the star, faster the nuclear fusion in the core. This leads to the high pressure and temperature in the central region. Due to this, fuel gets over in less time, and leads the star to end their life in a very short time, several millions of years, which is less than the low mass star. Whereas the low mass stars remains roughly 10 billion years in this stage by fusing the hydrogen into helium. Once the star reaches its last stage after fusing the hydrogen into helium, the core is accumulated fully with the helium. Now comes the red giant stage. So for the fusion of helium in the core, it needs high temperature to fuse it. Here comes the gravity which makes the core to contract. As the star shrinks, the gas around it infall towards it and produce the heat due to kinetic energy, and now the temperature of the core increases. There will be a layer of hydrogen molecule around the core. When the helium fuses in the core, it makes the layer of hydrogen to fuse. When the hydrogen fuses, it pours outwards and heats the layers and makes the star to expand. As the helium core continues to contract, produce the higher energy and leads the hydrogen layer to pour outwards. Due to the star grows bigger and bigger, as the surface of the star increases, the temperature of the star decreases. This stage makes the star more luminous and cooler. Therefore now the star leaves the main sequence stage and reaches the red giant. The massive star becomes the red supergiant and low mass star becomes the red giant. And now the fusion of heavy elements starts. As the star expands, it starts fusing helium in its core. The energy from the reaction prevents the star from collapsing. Once the helium fused to carbon, the process starts again until the ion forms in the core. Once the ion is formed, there is no further fusing because the fusion of ion needs so much energy. Due to this, the star does not able to sustain its equilibrium, it core collapse and cast a supernova. Now the star attained its last stage, the end of its life, a supernova. Supernova is a violent explosion event in the universe. Most of the star's material blown into the space. The low-mass star fuse till the carbon and then collapse, and explode into a planetary nebula and leaves a white dwarf behind. Whereas massive star fuses until the ion forms and then the core collapse and explode into a supernova, which blows all the matter of the star. The matter leaves behind the supernova is turned into neutron star or an black hole. This is the life cycle of an star, which starts from a molecular cloud and ends in a supernova. And now we have come to the end of the video. If you love the video, like, share and comment.